multiplicative thinking. And we have today one of our best assessors. This is Tanya Thompson, regional consultant with the Kentucky Center for Mathematics. And she'll be sharing some ideas about thinking, how are we going to assess and monitor this multiplicative thinking? So Tonda, I look forward to learning from you this afternoon.
Okay, thank you so much, Kelly. And thank you everyone for such good input and the conversation. This kind of pretty much leads right into what Jennifer was saying about the assessment, how important it is that we do assessment before we teach, because unlike what we used to do in the past, we used to teach and then to assess. But she's absolutely right. That assessment is vitally important to us. So today, Friday Eve of Memorial Day, I appreciate you joining us, and we're going to finish our series with developing multiplicative thinking on assessing and monitoring. So let's see. Oops, sorry about that. So that would be me. I'm your host, Tonda Thompson. And again, as we always introduce our website, for those who might be joining us who are new, you can always check us out on the KCM website. And some of the things that I'm going to share with you today, if you have not had a chance to look at our website, the resources can be found there, and they're very, very important and in the teaching process. So there's a site called PIMSR, or a part, once you go to the resources, you can click onto the PIMSR site, and that's where you're going to see some of the array cards that I'm going to use in the session today. The agenda, standards, research, we're going to look at an assessment task, the assessment task groups. We're actually going to look at one of those and take a look at what does the written computation methods look like, and end with the progressions of multiplication. It's going to be a little bit different, the progressions of multiplication, from what Belle done yesterday, and we'll discuss that a little further when we get there. Again, our math standards, we see multiplication hit very hard in 3rd grade, and also in our 4th grade when we get to our double-digit multiplication. The research that we're going to do today mostly comes from the Red Book, as we call it, Developing Number Knowledge. So if you have not had a chance to get the book and take a look at it, I highly recommend it. So one of the things that I just kind of wanted to take a minute to look at, when you look at the Red Book, there is 12 task groups for assessing different types of multiplication division. So I want to give you just a couple of minutes to look through each of those task groups, because there is, if you have not had the training, you can have the Red Book, and there is a task group like the multiplication with repeated equal groups. There is an assessment task that you can give the child, and there's also an individual instruction activity to go with it if they're struggling with that. So just take just a couple of minutes to read through each of those, because when we think of assessments, we think of one maybe universal screener, but just kind of take a look at all these individual assessment tasks that you can see in the Red Book. So when we think about multiplication, sometimes we often just think of maybe being able to do 3, 4 strategies, but actually there's so much, it goes so much more in depth than that. So one of the things that I really want us to, sorry, it's freezing and then it decides to work, sorry. Okay, so the first one that I'm kind of just, I can't, in the amount of time, really don't have enough time to touch on all of them. But one of the most important ones too that I think that sometimes our kids have struggles with, and maybe our teachers have struggles with, is how do we introduce the distributive, we call it distributive property. He refers to it as the distributive principle. So here is one of his tasks, and let me see if I can minimize that just a little bit. Okay. This is one of the task, assessment tasks that came from the Red Book, and it's checking to see how well they can use the distributed property principle in working multiplication. So if you notice, there's cards, and it tells you what to have on each of the cards. And it also gives you what to do and say. For example, display the first 3 cards. Read the first 3 cards. So you would ask the child to do that. Can you use those to help you work out 25 times 3? So when you look at the first 2 cards, who would like to share? How could those first 2 cards help with working out 25 times 3? Would someone want to talk about that just a minute? Anyone?
I look at it thinking with 23 is close to 25.
Okay.
So, I mean, thinking 2 less, I mean, you're just kind of breaking the number up some.
Yeah, you're exactly right. So that 25, if you noticed, we broke that 25 into 23 and 2. So we know 23 times 3 would be 69, 2 times 3 would be 6, and that's the same. If you put the 23 and 2 together, you would be 25 times 3. So yeah, actually, we just distributed that 25. Yes, absolutely. So now what about 49 times 3? How could we work that one out? And I can think right off just very quickly 2 different strategies that would work really well. But what are you thinking?
I was thinking doubling 23.
Okay.
Well, not doubling 23. That was the first thing that came to me.
Okay.
I was thinking taking 40 times 3 and 9 times 3.
Yeah, you could break apart. Absolutely. 49, 40 times 3, 9 times 3, the same thing.
My
Absolutely.
other strategy doesn't quite fit what we're doing.
Yeah. And that's okay. Yeah. And I did hear, I think it was Bonnie or someone that this week talked about how adding a group and subtracting a group.
Yeah, that was my other one.
Yeah, that's kind of the 2 that I was thinking as well. So now we could use the 50 times 3, which is a little bit different than the distributing out that 49. But yeah, absolutely. So those are some really important strategies that we want kids to be able to do. But I understand how difficult it is. Teacher says, I understand the importance, but how do I get them to do that? How do I move kids to think about that without just telling them and giving them a procedure to do? So let's see here. So one of the things that I have used oftentimes, and this is the array cards that I was telling you about that you will find in on our website. And if you look under the PIMSR part, you will see lots of different kinds of cards and area cards and array cards and different types of things to help with that. So now I'm going to try something here. I'm not the gurus like Cindy and Jennifer are with the Jamboard, but I just kind of quickly tried to use it a little bit this morning. And I'm going to need some help with you all too after this is all said and done to kind of give me some training. So I'm going to try to stop just a second here. Well, let's see. Let me go back to share screen. Sorry. I'm going to try to get to my Jamboard. Maybe I just minimize this. Okay. Can you see that? Is everyone seeing the small array cards on the Jamboard?
Yes.
Okay,
Yes.
perfect. Oh, I'm so happy. Good. Okay. So to save time, I did go ahead and just put the problem like I started with 12 times 2. And I think it was Bonnie that was sharing with you this week about using the L to how to use the area models and the array models. So the same thing we could do here is to help kids. How do they begin to see 12 times 2? So what do we know about 12 times 2? Once we circle that, because we know each one of these boxes is a 10 by 10 array. So we know that's, without having to count, they understand that's a 10. So what we did then is we looked at this, and just by looking at the 12 times 2, what do we see? we see 2 10s, right? And then we see 2 2s. So that's where they can see that that 12, we partition that 12 into 10 and 2. So we have 2 10s and 2 2s, and then we put those together till we get 24. So when we start with just using the distributive property, is that we want to make sure that that we start with even single digits. Here we've got a double digit times a single digit, but you definitely want to start with a single to the single. So why is it important that kids know this, and what does it have to do with assessment? Well, it has a lot to do with assessment, because oftentimes kids will have one strategy and just one strategy. So when we assess them, we see, okay, they have a strategy, but is it the most efficient strategy? And that's where goes back to kind of what Jennifer was saying. We have to assess to know where they are. Now that we know where they are, we have to move them to a higher level of thinking. We don't keep them at the counting on. We don't keep them at only, maybe all they can do is add a group or subtract a group, but we want them to be able to do some more efficient strategies. That is, and that's all based from the assessment that we give them. So, and again, I'm going to erase here. And if we had 12 times 12, what would that look like to a child? So we have 12 times 12. And just by looking, what do you notice? Do you know how many is here without having to do any counting?
It's easy to do 100.
Yeah, so you see 100. So we see this part here just alone is a 10 by 10, and we know that is 100. What else do we see? What about this little piece here? What do you know about this? We know that's 2 times what? 10, right? So now we know that is 20. What do we know about this piece down here? Let's just say this piece here first. We know that's another 2 times 10. So that is 20. And then what do we know here? We know this is 2 times 2, which is 4. And if you look how we have written it, 10 times 10, where did this come from? This 10 and this 10. This 12 was partitioned out to 10 and 2. And that's this part right here. Then we know that also 2 times 10. And that's this part here, that's 20. Well, we have another 2 times 10, and that can be here. And we also have then a 2 times 2, and this is 4. So for a child who is struggling just with a procedure, then it's so important that they get an opportunity to see this. Then once we give them some practice, we can also evaluate then again. We can kind of do an observation. As we talked about last Friday or the week before, when we talked about the different kinds of assessments we could use, observation is one of them. So let's take a look then. As a child is working here, how are they working it? Are they using the best strategy? So any questions there? How many of you have used the arrays for teaching double-digit multiplication, or even single-digit as far as that goes, but just using multiplication? How many of you are used to this type of setting? Now, I know this is not a quiet group. Okay, so another thing that I used to use when I taught third grade was these were the aerial models. So I would print these off. I think you can see them maybe. And I would laminate them. So when the kids had 7 times 9, you can see they partitioned that 9 into 5 and 4. And so then they drew the line and they multiplied this part and put the parts together. So we did a lot of work with that. They can also put the answer on the back and try to figure out what would the area look like. For example, 7 9s are 63. So you could have 63 written on the back of this. So when they pick a card that says 63, what could be the factors? So that would be a good way to use those. So I usually would just kind of keep these in a pack like this. And so when they're working on different types of things, they could use this also as a setting. Also, this is a nice, just an array grid, and they can also use that to help them here. They can color in their partitions here, and they can list here what they did, the steps. And if you wanted to stick it inside of one of these little erasable covers, that's a great thing. Or if you want to collect it to see again, it can be an assessment. It can be used as an assessment to see how well are they using the distributive property to help them to understand. And it's that conceptual understanding of that. Okay. Any questions there or comments? Anyone have something else that you would like to share with the group?
I just want to give you a shout out for those great, easy, quick assessments. I think it's always good that we talk from the Kentucky Center for Mathematics about how summative assessment is not the way to go, right? It is the on-the-fly, quick assessment, and the way you have those laminated and the way you have them put down in the pocket is a beautiful way to make that. I know that Mary Kate Duncan on today happens to be a teacher that I've actually seen in action doing these sorts of things in her classroom, doing the area model. So giving her
wonderful. And they really are beautiful. And again, just kind of have your handy dandy notebook or your clipboard, and as you walk around to see what their thinking is. To me, that is the most beautiful thing, is to actually hear and see how the kids are doing that. So, and that is an assessment. It's like Kelly said, we kind of always want to think about the summative, but the formative can be just having them to complete this task today. How are they doing that? And giving them taking some notes on their thinking on that. And still, maybe what is their struggles? As a classroom teacher, that's where the science comes in, is when we see the struggles, what's our next move? What's the next setting that's going to help them to understand that? And that's about assessing on the fly. And that's what we do every day as teachers. We don't wait till the end of the week. We assess daily and as they're working. Okay, so let's move on. Again, we've looked at some of Jenny Bay Williams's work, and this is just one of her tools. You won't see a lot of these types of tools in the Red Book. You see a lot of his assessment activities and instructional activities, but Jenny Bay does a really nice job of putting these observational tools so you can kind of do a little checklist of some different multiplication. And I think I shared those with you again the last time, but there it is again, and I do have it in the packet uploaded for you. So where do we start with kids when we're thinking about far as addition, subtraction, multiplication, division? Where do we start with them? Where do they start? So according to the Red Book and Dr. Bob Wright, we want kids to start with jotting. And if you can take a moment to just kind of look at that column, you will kind of see that the kids are just jotting down some of their thoughts and making sense of the stuff. But we don't leave them there. Let's just say we have a child and we have observation and we have assessed that they're still continuing to do the jotting. They haven't moved out of that jotting stage. So what we want them to do is somehow introduce them to that semi-formal. What does the semi-formal look like? So kind of take a look at that. What does that look like for a child? And then a lot of times people think that we don't want to introduce standard algorithm, but we do. And then again, our assessments, as we observe, as we look at the work that they've done, our assessment will let us know when it's time for them to move on to the next form. And so, and that final form there is the standard algorithm. That is where we want to get our children, but that's normally the place where a lot of our teachers want to start. So making sure that we give them that opportunity to write about their thoughts. What are they thinking? What's the best strategy that they have? Maybe it's the only strategy they have. And if that's the case, then how else could we think about it? I've had a lot of people say to me, the kids have been taught at home to do standard algorithm, and that's the only strategy they want to use. And my response to that is that's fine, as long as they have something else that they can think about it. If standard algorithm is the only strategy they have, then they have just memorized a procedure. They don't have that understanding that's going to be needed to help them further on once they get older in the upper grades. Okay, let's see. Whoops. Sorry. Sorry.
In this video, we're going to multiply 36 times 27. So we're multiplying a 2-digit.
Sorry. Don't want to go right there. Yes, yet. Hang on. Okay, so I guess I am there. Okay, so what I wanted you to look at, and I said and I had initially put in here progression of multiplication, and then Bill did it yesterday, so I guess I didn't change the title. So what I want you to look at is the Khan Academy's examples of teaching 2-digit multiplication. And then after you watch it, let's just have a brief conversation about what did you see.
Number times another 2-digit number. And the way that we're going to tackle it is we're going to first multiply 36 times 7, figure out what that is. Then we're going to multiply 36 times 20, figure out what that is, and then add those two numbers together. And what I want to do is first to do this, just show you the process for how to multiply these two numbers. And then I'm going to do it again where we're going to think a little bit more about what the different numbers represent. So first, let's start with the process. So I'm going to multiply 36 times 7, or 7 times 36. So I can start in the ones place. 7 times 6 is 42. Write the 2 down here, and then the 4, which represents 40, I can put in the tens place. 7 times 3 is 21, plus 4 is 25. So I could write the 25 right over here. There's no place to carry this 2, so I just wrote the 2 right over here in the hundreds place. Now, let's move over. So let me clean this up so we don't get confused. So we've just figured out what 7 times 36 is. It is 252. Now let's worry about what 36 times 20 is. And so what we're going to do is we're going to throw a 0 right over here, because we're now going to multiply 36 times something in the tens place. This isn't just a 2, this is a 20. So 2, or I should say, well, let's just go with the digits right now, and then we'll think about it in terms of place value in the second time around. 2 times 6 is 12, right? The 2 right over here, carry the 1. 2 times 3 is 6, plus 1 is 7. So we just figured out that 36 times 20 is 720. And just think about what would have happened if we didn't put the 0 here. Then we would have figured out that 36 times 2 is 72, but this 2 isn't just a 2. This is a 20. So 36 times 20 is 720. And now we can add these two things, because 36 times 27 is the same thing as 36 times 20 plus 36 times 7. So let's add these two numbers together. 2 plus 0 is 2. 5 plus 2 is 7. 2 plus 7 is 9. And we get 972. Now I'm going to do this exact same problem again. But this time, I'm going to really talk about what these digits represent. Hopefully the first pass, you kind of saw the process for doing it. Now we're going to think about what these digits actually represent. So we're going to multiply 36 times 7. So 7 times 6 is 42. We would write the 2 in the ones place, and then the 40 we can write in the tens place. This 4 represents 40. 7 times 30 is 210, plus 4 is 250. 250, and we already had that 2 in the ones place, so we get 252. 36 times 7 is 252. Now let's clean this up. Now let's multiply 20. 20 times 6 is going to give us 120. So let's write the 20 in the tens place and then carry the 100, or carry the 1, which represents 100. Now 2 times, or I should say 20 times 30 is going to give you 600, plus 1 more 100 is going to give you 700, So we just figured out that 36 times 20 is 720. This 7 is in the hundreds place, 2 in the tens place. And then we can add again.
Okay, we're going to stop right there. I think I've heard enough. So give me some thoughts. What is your thinking on this when you saw this? What's your thinking?
I wouldn't say one method or the other is any easier to understand. And I've learned the first method as a child.
Yeah, exactly. So what's missing from this?
Conceptual understanding.
Yeah.
And there's no visuals. You're telling us everything. You're telling us this is a 10. You're telling us that this is a 100. But I can remember, it almost brings back these bad vibes when I was in school and I was trying to wrap my head around, he calls it a 2, but then he calls it a 20. And I really don't see all of that stuff. So when we introduced, and this is called a standard algorithm, when they introduce the standard algorithms too soon, kids have no understanding on what 36 times 27 really is. And he even talks about adding this 0 here. Well, it would be 72, and then if we have to add this, I mean, I was confused. So this we cannot introduce too soon, or kids are not going to get it at all. That's why it's so important to use those dot arrays, those rectangular arrays, to use bead racks, and to use that types of stuff when we go back to the assessments, like where we're talking about the jotting here. It's very important that we don't start here with the standard algorithm, whichever type you wanted to call the standard algorithm, but we allow kids to live in these other 2 phases before we arrive here. So oftentimes, too many times, we wonder why kids are struggling so much with multiplication, and it's because we have not allowed them to live enough in the conceptual where they honestly understand. Anyone else? And I kind of thought that was interesting because it came from Khan Academy, and I was kind of looking for something like really that they would understand. So I can see how parents would go straight to that and say, let's just memorize what he's doing here, even though I think he tries his best to make it conceptual, but it's still bare numbers. And I think that's what we have to understand. Anytime we introduce, if it's multiplication or if it's division or if it's fractions, if we start with a bare number or we get there too quickly, we're going to lose a lot of kids. And I think that's what happens. Okay. Any other questions? That's pretty much all that I have. I know it's Memorial Day and it's 30 minutes is not very long. I think I have 1 minute left. So I did pretty good. But I did hope that you took away from this the importance of assessing daily. And it's not a summative assessment, but we assess and then we move them to higher levels of higher strategies and not just leave them, even though it may be a conceptual one. That's where they are, but we have to assess and then we have to design instruction to meet where they are to move them to the next level. Anyone else want to share anything that maybe you try or that you do that the rest of us can learn from that as well?
One of the things about assessment that I think is important, Tonda, is a child's ownership of their own learning, that they understand what their goal is and why their teacher is assessing them, and then giving them, making sure that there's a feedback loop. Assessment is not something we do to children. Assessment is something that we do with children to move them along a journey. And it's so important that kids know that that is the goal, because when they own it, then they can move themselves along that continuum. And I say that's from kindergarten all the way up through high school. So
Absolutely. Beautiful. I'm glad you said that, Kelly, because that is exactly the truth. That
And I
is,
think,
yes. Go ahead.
I think the importance of using word problems.
Absolutely. Live in the real world. Absolutely. Amy, I agree. Yep. I agree, Amy. Real world stuff is so important because, you know, can you really do math if you can't problem solve? So it's kind of like reading words. I like to think of it, you know, you may be able to read 100 words in a minute, but if you can't comprehend, can you really read? And I feel the same way about problem solving. You know, you can know all these facts, but if you can't problem solving, can you really do math? So absolutely. Thank you for sharing that. And I'm going to stop sharing, Kelly, so you can end with us.
So it's always important that we kind of bring you some of the best mathematics research that there is out there. We have had a continuous stream of 9 weeks of content that really gives everyone something to think about. This week it was the rest of multiplicative thinking. There is a 1 week, 5-day series that was before this. Then of course there was this. So together, these series are meant to give you just a little dose of something to think about, some resources that we believe are some of the best that are out there. And our goal is to have you drive thinking in your schools by circling back to these recorded sessions and interacting with them in a different way. Today is a special day for us. This is the end of a 9-week series. It is not the end, but it is the end of the 9-week series. When I look at who's on here today, it is our KCM treasures. And that is what I call you because you very much are a treasure to us at the Kentucky Center for Mathematics. Our goal is to have a tribe of folks, both in the state of Kentucky and across the nation, for which this is what we do. We believe in and work for teachers whose goal it is to bring conceptual understanding to children so their mathematics knowledge is a door opener for them. We believe that mathematics is a skill that really gives you a vibrant life, whatever that life might be out there. So I would like to have those of you that have been with us for the whole session to unmute your mic and give us one of the things that you really have benefited from in regards to attending these sessions, because you guys are our diehard folks. So let's take a couple minutes to hear from our KCM treasures.
It's given me a resource bank. If I need something, now I know exactly where to go find it. And because I've been here and seen all the sessions, I know what handouts or which session to select. So it's really given me a huge resource bank, especially in not knowing what school's going to look like next year. So I thank you all for that.
And tagging on to her, I have a document I'm trying to make for some summer math activities. And Kelly, I have your name typed into 5th grade. I said Kelly DeLong fractions because your presentation I want to, and that's how I think about it. I'm like, okay, who did what, and fine. I've already been using some of that. And that's what I love. I mean, makes, no matter how much you spend on a professional development, if it's free or not, if you can use it right away, it's well worth it.
Fantastic.
Well, I just want to say thank you so much to everyone at KCM. I kind of stumbled upon you, and I'm just disappointed that I didn't find it right at the beginning. It's been actually something I've looked forward to every day, to be here at 2 o'clock, and there's never a day that I don't walk away with something new, or some days it's just confirming the practice that you are on the right track, because sometimes not everyone feels this way. There are people at my school that encourage kids to know their facts, on time tests, and they want them to know the algorithm. So it kind of is nice to know, like, stay on the path that you're on. So I appreciate everything, and I'm just so sad, but so appreciative. And thank you so much for sharing. That's the one thing I love about teachers. They're usually just so giving and want to share. Like my knowledge, I want you to have it. So I'm so appreciative of everyone sharing their expertise.
And I think tagging on to Stacy, just the importance of community, especially right now, when we kind of feel like we're on our own and having to tackle on all this and make all these decisions and figure out all of these things. When you have a resource like KCM putting this information out here and making you feel such a part of a math community, and not just a math community, but like the most legit math community in the U.S. is coming out of Kentucky right now. I'm very biased, but I do think it's true.
I think for me, these sessions, it's introduced me to some new people. I knew Cindy and Dee pretty well from trainings, and so I've enjoyed getting to hear from different regional consultants, and even when we did the interventionist, I like hearing different voices, and I think it kind of helps solidify what we do. And people who talk the same talk, like someone said, sometimes you're running into people who maybe aren't using best practices, and we're trying to have those conversations. So maybe now it's like, well, let's sit down and like look at these videos or read this book together, even though I've suggested reading articles and things like that. Maybe that's where I need to go so we can kind of get on the same page.
So we always want to remind you that our most vibrant platform is our social media. So I hope, even if you just dabble in social media, what I hope that you will do is like us on Facebook and then tag us on Twitter, because any programming and Instagram, but any programming that we have that comes out of the Kentucky Center for Mathematics is always the first thing that's on there is a vibrant social media. We have Lina, who works behind the scenes, to do that. So that's how you will find us, you know, in the initiatives that we have going on the horizon. The second place is that from the bottom of our heart, we really are resources for each of you, Kentucky and the nation, in regards to mathematics, to the way that math is taught, way up through high school and adult education. We are easily found on our webpage, the KentuckyMathematics.org webpage. Over to the side is contact us. If you go down, there's pictures of all of us, and each of our email addresses are there for us. So if you want to see, if you want to talk to Tonda about X, if you want to talk to D about Y, if you want to ask me a question, all of us are easily found on there. So we want to encourage you to, after this is, you know, as we culminate, and you're needing some resources or thinking about some things, always reach out to us. My heart will go, oh, look, it's Jennifer. Oh, look, it's Stacy, in my email. And so as that goes on, and look for our programming. Our programming continues to be vibrant. We are innovators. This week on our daily emails that I'm sending out, we believe that we can blaze trails that other people can't blaze, because we've got the best people in the nation working hard behind the scenes to make that happen. And so stick with us. We're going to be out there innovating, and you just never know what's next out there on the horizon. So from the Kentucky Center for Mathematics, we want to thank each of you that are here today. You are our KCM treasures, and we appreciate your dedication to this series. And we thank you so much. So we're going to say goodbye.